All right. Cool. So let's start with a very good statistics. Now, did you people know that out of all the people who take GMAT, only 6% of them essentially end up scoring a 720? Now, this score of 720 is only achieved by 6%. That's one out of 16 people. And a very good percentage of those 6% use e-GMAT. And why do they do that? We'll learn about that in this session. Now, I have a question from Alston. There's an echo coming in the background. Now, Alston, it might be because you are joining us from the browser. If you're joining us from the browser, please ensure that you join from the Adobe Connect app. In the app, you don't have any such issue of an echo, right? All right, so let's start off with the next part. Now, in this part, we are going to discuss about algebra. But if you are struggling making a plan for your studies, then what I would suggest is you can book a one-on-one call with one of our GMAT strategy experts. Now, I've launched the link to all of you, and you can see the dates. You can book a call with our strategy experts, and they're really a very good team. They'll help you out to create your optimized study plan for your GMAT. And these people, they're really good at their job. I've seen some wonderful results from their end. So do book a call, book this one-on-one call. It's a first come, first serve basis. And if you do not get a slot, then do write to us at support@egmat.com, which would help you to, we'll try to get you a slot for that. All right, so there will be two parts to this webinar. We'll be having a live session, and that would go somewhere around 120 minutes. And then we'd have a question and answer phase where we'll be answering all your doubts that you have pertaining to your preparation or anything in algebra or essentially the entire GMAT quant. Let's now discuss the purpose of this session, and for that I'll just here. Okay. So the purpose of this session is the first thing that we are going to learn is how to apply the concepts that we have learned in algebra in the GMAT context. That is in questions that are tested in the GMAT. So the basic concept files were already covered in the concept files, and I hope you people went through that, and that is what we assume, because to answer the questions that we would be tackling today, those were the prerequisites. The next thing that we would be learning is the process of solving questions. Now, not only learning all the concepts is important, you also need to understand the processes of solving those questions, and that part of application would really help you to get to that target GMAT quant score of yours. And then for each of the subsections, and I'm going to talk over the subsections after this, and for each of the subsections, will be talking about the key takeaways, and it will be really nice if you note them down so that in all the questions that you solve in the future, those are kept in your head and you don't make the same mistakes again. I'll also try to highlight the possible gaps in your current preparation so that you can work on them and then get to a better position as far as GMAT algebra is concerned. Right, so let's understand how would we proceed in the session. So the topics that we would be covering in this session would be linear inequalities, quadratic inequalities, absolute value equations, and absolute value inequalities. So we'd be having a warm-up quiz, and this warm-up quiz would essentially contain questions which are around the 550 to 600 level questions. We'll be having 6 PS questions, and this would just be a teaser to you before the main part starts. In the main part, we would be discussing 8 questions, and these 8 questions are the GMAT level questions. You can expect good questions there, and the last 3 questions specifically are really good. So we'll be discussing around 14 questions in this webinar. All right, with that, let's start the warm-up section. Now, these are basic questions on algebra. After we are done with this, I would also give you a feedback on your current conceptual knowledge. And the solutions that we would be discussing here would not be that detailed, but it would be much detailed, and you won't be having any issues at all. In case you have any issues, please post your issue on the Q&A pod, and we'll take care of that. Right, so let's get a pen and a paper, and one more thing out here. So basically this session would not be a timed session. What I would do is I'll ask you people to select, let me put in the poll here. I'll ask you people to select still solving. Now can you guys please select still solving? I have, let me get to 70 still solvings, please. Let's have 70 still solving. I have 48 people, 50 people. Another 8 people, please. I have 62. Let's get some more people. Two more. All right, thank you. So what I would do is, 70 people have selected still solving. Now you guys time this session. So whenever I see that 80% of these 70 people choose another answer apart from still solving, I'll call time. So you essentially would be conducting the pace of this session, would be moderating the pace of this session. Right? So let's get to the first warm-up question, and this is the first warm-up question. All the best, guys. All right, another 5 seconds. 4, 3, 2, and 1. So what I'll do is I'll end the poll here, and we'll move into the second question. And you people already know the housekeeping activities. Let's click on still solving. Let's get 70 people in still solving, and I'll give you the second question. We have 60 people, another 10 people, 68. All right, that's good. So let's move on to the second question. All right, another 5 seconds. Please put down your answers if you have not marked it in the poll. 4, 3, 2, and 1. So what I'll do is I'll end the poll here and let's move into the third question. All right, please select a still solving, please. We have 40 people. Let's get to 70. 10 more. 69 and just one more. Please select still solving. All right, so I'll close broadcast results and let's move to the third question. Here you go. All right, another 5 seconds for this question. So please mark your answers if you have not marked them yet. 4, 3, 2, and 1. So I'm gonna end the poll here. And now let's discuss the 3 questions that we have solved so far. So let's go to the solution of the first question. Before that, let me bring out the poll. All right, let's see how you people did. So I'm going to broadcast the results. And I can see for the first question, 72% of you marked option B and around 10% marked option A. So let's move to the solution for the first question. Now in this question, it was asked what is the range of y if 4y plus 10 is greater than minus y. Now to solve these kind of algebraic inequality questions, a proper way is to bring all the similar looking terms on one side of the inequality. So what we would do here is bring minus y to the left hand side of this inequality and take plus 10 to the right hand side. So if you do that, what do we have? We have 4y plus 10 plus y is greater than 0, which essentially means that 5y plus 10 is greater than 0. And then we take plus 10 to the right hand side of the inequality. So we get 5y is greater than minus 10. Now, when I divide both the sides of this inequality with 5, I get y to be greater than minus 2. And hence, option B is the correct answer, which 72% of you got right. And to solve this question, the only thing that you need to keep in mind is the basics of inequalities, taking the like terms to one side of the inequality, and that would be it to solve this question. So I hope this question is clear to all of you. So I'm going to do what I'm going to hide the poll here and let's move into the second question. First of all, let's see how you people did it. So let me broadcast the results. And I'm seeing that 56% of you marked option B, and then 14% of you marked option C, and almost an even split between option A and option D. All right, let's move into the second question. Now, in the second question, it's almost synonymous to the first question, but a little bit involved because now we don't have one inequality, we have two. So I need to find out the range of y when x minus y is greater than minus 3 and minus 2x plus 3y is greater than 4. Now, to solve this question, the first thing that we need to do is we need to find out the range of y. So let's get to the value of y, and we need to essentially cancel off x. So we don't need x in any of these inequalities, right? So what we are going to do is multiply the first inequality by 2. When I do this, I get 2x minus 2y to be greater than minus 6. Now, since these two inequalities have the same sign of inequality, and we know that inequalities with the same sign can be added together, I would add these two inequalities up, and then we would get to the value that the value of y is greater than minus 2. This is only done to cancel out the plus 2x and the minus 2x that we had. Now we had to find the value of y, right? So we did not need x. So this was what was required to be done for this question. Now in any question where you are given, let's say, two inequalities and you need the value of one, try to get rid, or I would say that try to eliminate the second variable that's present in the inequality. That is the process to solving these questions. So for solving this question, we need to remember two things. That first of all, the process that I just talked about, when you find out the value of y, then you just need to eliminate x. So you need to get comfortable going into that process. And the most important takeaway from this question is the inequalities with the same sign can be added together, right? All right, let's move on to the third question. So I'm going to hide the poll here and let me bring in the third question's statistics. All right, let me broadcast the results. And I see that, okay, it's almost an even split amongst options A, B, and C. Okay, I have a question here from Emmanuel, who asks me, on what occasion do we change the inequality sign? Now we'll get to that part, but as of now, let's keep that. We'll get to that in the next question itself, right? Okay, let's move on to the third question and see. Now in this question, the question asks me how many non-negative integral values of m do the two inequalities satisfy, and I have been given two inequalities. I need to find the value of m. So what I would do is I would essentially do what? I would try to eliminate n from both these sides, from both these inequalities. Now I can see a minus n here and a positive n here, and also the sign of these two inequalities are same, so we can just add the inequalities. Once we add both the inequalities, we get the value of 4m to be greater than minus 10. Now, one very important thing here is when we multiply this with minus 1, the sign of the inequality would change. And Emmanuel, I hope this answers your question. So whenever I have an inequality and I multiply that inequality with a negative number, the sign of the inequality would change. So from minus 4m greater than minus 10, I need to find out the range of m. So let's convert minus 4m into m. How would we do it? I need to multiply it with minus 1. So then you can see that the greater than sign now becomes the less than sign. Right, so 4m is less than 10, which essentially means that m is less than 10 by 4, which is equal to 2.5. Now, if m is less than 2.5, the possible values of m are 0, 1, and 2. Why? Because there's a very important constraint that's given in the question, which is this. How many non-negative integral values? So yes, m is less than 2.5, but I cannot go into the negative integral parts because m is a non-negative integer. So these are the three possible values that m can take, which makes option B the correct answer, the option C the correct answer choice for this question. Well, people who got options A and B, so people who marked option A and option B, where did you falter? I'm opening this short answer poll. Why don't you tell me where did you falter? Let's get some more answers in the short answer poll, please. Where did you falter? So a lot of people and almost every one of you tell me that you did not include zero as in your answer. Now, basically, that is something really important, right? So here, what we have a very important constraint, and that is the reason you have to be very observant reading the question. If you miss some part of the question, even if you do the entire question because of some small mistake, the entire question becomes incorrect. So please, from the next question onward, I would want all of you to make sure that you keep a note of the constraints that's given in the question. So the takeaways from this question is that inequalities with the same sign can be added together, and the sign of the inequality changes when we multiply that inequality with a negative number. Right? Okay, let's now move into the fourth question. So what I'm going to do is now we'll solve two questions now and then discuss when both these questions are done from your end, right? So you know the process, click on still solving. Let's get 70 people in the still solving. We have 39, 51. Okay, some more people, please. Okay, that's great. Now let's move on to the fourth question. Best of luck, guys. All right, 5 more seconds for this question. If you have not marked the answers, please mark the answer in the poll. 4, 3, 2, and 1. All right, so I'm going to end the poll here and let's move into the next question. So you already know how to do it. Click on still solving, please. Let's get 70 people. Click on still solving. We have 55. Let's get 10 more people. 67, 3 more. 67, still at 67, 68, 69, one more person to 70. All right, thank you guys. Let's move on to the fifth question. All right, last 10 seconds, guys. Last 10 seconds. Let's mark the answers in the answer poll here. 5, 4, 3, 2, and 1. So I'm going to end the poll. And now let's go to discussing the answer for the fourth question. Now, these two questions were a little bit involving than the previous three questions, right? So let's answer the first question. That is question number 4. And let's see how you people did. So let me broadcast the results. And I have almost 50% of you telling me that the answer for this question is, for the fourth question, is option C. All right, and also around almost 1/4 of the class going to options A and B. All right, so let's move into the solution of question number 4. Now, in this question, it is asked that what is the range of x? So we need to find out the range of x. If we have been given an equality which says x minus 2 times x minus 3 is greater than 0. Now, let me ask this question to all of you. When is the product of two numbers positive? Let me reopen the poll, and why don't you answer in the short answer pod? When is the product of two numbers positive? Yes, when I have both the numbers positive or when both the numbers are negative, right? So when both are positive or both are negative, Correct. So let me end the poll here. And yes, that was the answer that I was looking for. Someone also said that it's square, and yes, that's also one of the very important points which we would be, getting to in the next question. So let me clear all the answers here and move on to the next part. So when both these numbers, x minus 2 and x minus 3 are positive, that is the case we're looking. And the second case is when both of these two numbers are negative. So if x minus 2 is greater than 0, that is positive, that means x is greater than 2. And if x minus 3 is greater than 0, that means x is greater than 3. Now, if you compare these two expressions, I am looking at a value of x which is greater than 2 as well as greater than 3. Then if I combine both these equations, we would get the value of x is greater than 3. We'll do the same process for both of the numbers being negative. So x minus 2 is less than 0, which gives us x to be less than 2. And x minus 3 is less than 0, which gives us x to be less than 3. And again, when I combine both these in equations, I get that the value is the value that I would get is x less than 2. Now, when I get to this part, I'll just take these two values and then mark the answer, which is from minus infinity to 2 and from 3 to infinity. And I hope this question is clear to all of you. So one very, very important takeaway from this question is when the product of two positive numbers and the product of two negative numbers is always positive, right? And we also use the basic conceptual knowledge to get to the right answer. All right, let me end the poll. Let me hide the poll here and move on to discussing the fifth question. But before that, let me broadcast the results. Okay, so I'm looking at 45% of you marking option C, and a fair share of people marking options A and B. 18% of you have marked option D. Now, another part, another concept before we move into the next question is that the same question, question number 4, can be solved using a new approach known as the wavy line technique. Now, to understand in this slide, we'll try to understand the wavy line method to solve these kind of questions. What you need to do is, we had this inequality with us, right? What we need to do is essentially visualize these two numbers that we have here, minus 2, minus 3, as we have in the inequality. Visualize both these numbers when you convert them to the roots of the equation on the number line. So minus 2 becomes 2 and minus 3 becomes 3. Now, we have three different regions for the possible values of x. One region is from 3 to infinity. This is one region. The other region is from 2 to 3. And lastly, the third region is from 2 to minus infinity. Now, in these three regions, what we need to check is, for any values of x, are we getting the product to be a positive or a negative value? Now, if x is greater than 3, that is, we are looking for this specific region. Now, if x is greater than 3, both x minus 2 and x minus 3 are positive numbers. And we know that the product of two positive numbers is also a positive number. So this region, the first region, is a valid region according to the question. If x, let's say, belongs to the second region, that is, belongs from 2 to 3, then the value of x minus 2 is positive. However, the value of x minus 3 becomes negative. And when I multiply a positive number with a negative number, the product that I get is negative. So this is the zone where my question does not satisfy. So this cannot be the answer. And similarly, we'll do the same process for the third part. That is, when x when x is less than 0, less than 2, I'm sorry. Now, when x is less than 2, both of x minus 2 and x minus 3 are negative. And you people already told me, right? The product of two negative numbers is also is a positive number. So this is also a possible value that x can take. So region 3 is also a possible region that I can answer. I can include in my answer. So that gives us the answer for this question as option C. Now, Shobit has a question for me, and he asks, why is x is equal to 2 and x equal to 3 included in the answer? No, they are not included in the answer, because you can see here that we have used open brackets. Open brackets mean that the values attached to that bracket is not included. When we used close brackets, so when I write like this, comma something. So this means 3 is included. Now this is a closed bracket. Here it's not a closed bracket, right? It's an open bracket. Okay, RC has a question. Shouldn't it be -2 and not 2 in the diagram? No. So we are looking for roots, RC, and that is the reason we'll take this as to be equal to 0. And then when x minus 2 is equal to 0, essentially means that x is equal to 2, right? So we're looking for the roots. All right, now let's move into the fifth question. The fifth question was a bit more engaging than the fourth question, a bit more involving than the fourth question. And someone answered that squares are always positive, right? Now in this question we are asked what is the range of values of x, and then we have been given a fraction, that is x minus 3 divided by x plus 4 is less than 0. It's negative. Now in this question what we need to just give me a moment. Yeah, what we need to see is, can we multiply both these numerator and denominator, or essentially both the sides of this inequality, with x plus 4? We cannot, because x plus 4 can be negative or positive, right? We do not know anything about x. So we cannot directly multiply this inequality with x plus 4, because the sign of inequality may or may not change. So what we do is multiply by x plus 4 whole square. And I'm going to open the short answer poll here. You people are going to tell me, why are we multiplying it with x plus 4 whole square? What is the reason behind multiplying this inequality with x plus 4 whole square and not x plus 4? Absolutely correct. Absolutely correct. Squares are always positive, right? Squares are not negative. So x plus 4 whole square is always a positive number, right? Now whole squares are always greater than equal to 0, but since here we have plus 4, so we would essentially take this to be a positive number. So I'm going to end the poll. All right, let's get back to the question. Now when I multiply this inequality with x plus 4 whole square, I can cancel off x plus 4, 1x plus 4 from the numerator and the denominator, and then I end up getting somewhat similar to the last question, right? An expression which is somewhat similar to the last question. Again, what we would do is try to write this entire piece in terms of their roots, and we are going to visualize the roots over here. So what are the roots for this inequality? We have -4 and +3. Again, we'll take the three sections. So one area is from 3 to infinity, the other area is from -4 to 3, and the third area is from -infinity to -4. Right, so with this, with this approach, the wavy line technique that we learned in the previous question, solving this question really becomes easy. Okay, so I have a question here from Nipun, who asks me why to even multiply a square in the first place, because if we use the options, then we can reach to the answer in 15 seconds. Yes, definitely. For this question, if we use the options, we can reach to the answer in 15 seconds. But the question that we need to ask is, in the GMAT level difficulty questions, this definitely won't work. The process definitely won't work. In difficult GMAT questions where we would be having a lot of variables, plugging in values would work for some questions, would work for easy questions, but definitely would not work for the difficult questions. Right, so that is what we need to check. Okay, Sadia has another question for me. Why is it not D? It's not D because I need to find out the values which are less than 0, right? So I need to find out the values where I'm getting a negative part in the wavy line method. So that is the reason we have marked option C as the answer. Right, with that, let's move on with the next question. Okay, Ganesh has a question. Can you explain the wavy line technique once again? Sure. So what we do is first look at the inequality at hand. Then from the inequality, we'll try to get the roots of the inequality. Now, what are the roots? We just need to calculate each part and take that each part to be equal to 0. So when x plus 4 is equal to 0, one root of the inequality is -4. When x minus 3 is equal to 0, the other root of this inequality becomes 3. So now we have the 3 regions, and then you can take one region at a time to check whether your answer aligns with the answer, aligns with the question or not. I hope, Ganesha, that is clear to all of you. That is clear to you. All right. Let's Yes, Krish. It would also work if I have three parts of an inequality like you have mentioned in the question. If I have x minus 1 times x minus 2 times x minus 3, what I need to do is essentially put the roots. So the roots would be 1, 2, and 3, and then check for the wavy line. The approach remains same, and we can solve all the questions through this approach. I hope that clears your doubt as well. All right, now let's move on to the sixth question. So what I'm going to do here, I'm going to hide the poll, and let's go to the sixth question. What I would request all of you is to mark still solving, please. Okay, almost 60 people. Let's get another 10 people marking still solving, and let's then move on to the sixth question. The sixth question is a really nice question, guys. Thanks a lot. Let's move on to the sixth question. All right, 5 more seconds for this question. 5, 4, 3, 2, and 1. All right, let's look at the answer for this question. So I'm going to end the poll and broadcast the results so that you people can see what you have marked. So 70, almost 75% of you have marked option C as the right answer, which I believe is absolutely correct. And I have a fair share, 8% and 11% marking options T and A respectively. So let's get to solving this question. Now, this is a question on absolute inequalities, right? In this question, we have been asked which of the inequalities is equivalent to x plus 3 being less than equal to 5. Now, to solve this question, what we would do is, since we have an absolute number, we'll first substitute to reduce the complexity of understanding. So we'll substitute x plus 3 and we'll take that to be z. So now my question becomes really easy. I need to find out whether z is less than 5 or not. So if z is less than 5, then we manipulate this information because we have a modulus sign. So when we open the modulus sign, we can say that the value of z can lie between -5 to +5. Now, we have to answer in terms of x, right? We cannot answer in terms of z. So what we would do is replace z by x plus 3, because initially we had substituted the value of z. So when I replace z with x plus 3, what I have is minus 5 less than equal to x plus 3 less than equal to 5. Now when I add a minus 3 to all the three parts of this inequality, and what is the reason I'm adding a minus 3? Because I will get a x in the middle, right? I can eliminate the 3 part from here. So when I add a minus 3, I can see when I, upon simplification, the range of x becomes from minus 8 to 2, which means option C is the correct answer for this question. Now, to understand absolute inequalities in a much better fashion, what we would ask you people is to interpret absolute values as distances between 2 points. So let me give you an example. For the same question, and let's draw parallel to this question. Let's say you are standing at point 5 and your friend is standing at point 2. Now, to calculate the distance between the two of you, to calculate the distance, what do? You would subtract his distance, or where he is standing, from the part where you are standing, right? So you subtract 2 from 5 and then say, okay, all right, the distance between you and me is equal to 3 units. Here as well, we'll assume the same thing. So what we do is, from my distance, that is 5, I subtract, from 5, I subtract his distance, which is equal to 2, and then get to the final answer, which is 3. So here as well, we'll do the same thing. Now, we have to subtract, keep this in mind. So from x, right, we are subtracting some value, let's consider that to be y, and then I get the distance to be less than equal to 5, right? The distance between these two people should be less than equal to 5, and then using this we convert what we have here. So we had a plus 3, but I need a minus y, so the value of y has to be minus 3. Only then, when I do a x minus of minus 3, that is, subtract the distance between that friend of yours from you, then you get to a plus 3. So minus times minus becomes a plus. And this is the visualization that you have to keep in mind to consider absolute value equations in terms of distance between you, or essentially a variable, and another variable or a constant in the same question. So here the distance between x and minus 3 has to be less than equal to 5. Now, so x and minus 3, so I do not know the value of x, I just have the value of minus 3. I plot the value of minus 3 on the number line. I'm looking for distances which is less than equal to 5 units. So in the left hand side, I go to minus 8. In the right hand side, I go to plus 2. In the same approach, we'll be trying to solve all the questions that we would be having in absolute inequalities. This is a very nice, way to figure out the distances between these two places. Another point that you need to take a note of here is, here, if you calculate in terms of distance, less than equal to 5 means the distance between the 2 points is less than 5 units, right? Only then we can do this. If we have a greater than 5 units, we would be having everything apart from this range. So we'll be having the range from 2 to infinity and from minus 8 to minus infinity. Is this concept clear to all of you? Please mark a yes if it is. The concept of taking absolute values as distances between 2 points. Okay, I see a lot of you saying a yes. I'm really happy for that. For people who are having some kind of an issue, I would say to try visualize the points, and then I hope you would be able to reach to that part. Now, what I'll do is I'll end the poll, clear all the answers. All right. So we are done with the 6 warm-up questions, and let's look at the warm-up feedback. Now, I would say that to solve all these 6 questions, the major thing that you need to have in your arsenal is a 200% clarity in the basic concepts. Now, all the 6 questions were around the basic concepts itself, right? And if you scored less than 100% in these questions, then I would suggest you to go and go to that free trial. We have already given you the access, in the emails that we have forwarded. Or if not, just log into e-GMAT. You can see the free trial page, and in that, cover all the recommended concepts in the course, that is on inequalities and on absolute values. So basically, these warm-up questions was just a teaser for GMAT questions, and GMAT questions require a much advanced level of application of these concepts. That is the reason I want all of you to be 100% sure, or rather 200% sure in all the concepts that we have learned. Right? And one other question, let me reopen the poll in the short answer. Tell me, how many questions out of these 6 questions did you get correct? How many questions out of these 6 did you get correct? Okay, so the majority is in the 4 range, and I feel that the last 2 questions might have given you some trouble, and the third question as well might have given you some trouble. All right, with that, let me end the poll, and we will be moving into the GMAT context questions. Now, before that, I've already told you if you access the e-GMAT free trial, you get the access to all these modules, right? So go to your e-GMAT free trial, and you can see all these videos for free. So, and you can also take the practice quizzes to understand what is your level of preparation. Right, with that, let's move on to the next question. So I'll bring in the first question. Just give me one moment and let me get you the poll. And it remains the same. The process remains the same. So what you need to do is mark still solving. Let's get 60 still solvings, please. We have 28, 32, 40. Let's get 20 more people. Okay, let's get to the point of 60. 59, 60, that's it. Thank you. All right, let's move into the first question. All right, another 5 seconds. Please put your answers. It's a very easy question, not that difficult, correct? 4, 3, 2, and 1. Let me end the poll, broadcast the results, and I see that 66% of you have marked option C as the correct answer, which I guess yes is the right answer for this question, but we'll just find that out. So let's move into the solution for this question. Now, in this question, we had to find out the range of x if 16x plus 32 is greater than 48x plus 96. Now, we have to find out the range of x, and we have been given this inequality. As we have already learned, to solve these kind of questions, what we do is bring the similar looking terms in one side of the inequality. So let's bring all the terms with x in the left hand side, and all the constants go to the right hand side of this inequality. So when I bring 48x to the left hand side, what we get, uh, I'm getting a comment that I'm not being able to hear, that you people cannot hear me. Let me put out the poll of audio. Guys, can you hear me clearly? All right, then maybe Wakas and Sadia, you have an internet issue at your end. All right, let me hide the poll. All right, so let's get to the question. So yeah, we bring 48x to the left hand side of this inequality. We take 32 to the right hand side of the inequality. So what we have is 16x minus 48x, which becomes minus 32x, and in the right hand side we have 64. Now we need to find out the range of x, and I have a minus 32x. So I multiply this inequality with minus 1. When I do that, the sign of the inequality would change, right? And I hope you people have done this. So this was a very important point in this question. So I change the sign of the inequality from greater than to the less than sign, and then I see that 32x is less than minus 64, which means that x is less than minus 2. So for that, we mark option C as the correct answer. Right, with that, I hope this question is clear to all of you. So what I'm gonna do is I'll clear all the answers, reopen the poll, and before I move into the next question, you know the rules. You select still solving, right? So please select still solving. Let's get 60 people mark still solving, and then I'll give you the second question. All right, thanks a lot. So I'll close broadcast results, and let's get to the second question. All right, another 5 seconds for this question. 5, 4, 3, 2, and 1. Okay, let me end the poll here and broadcast the results. So I see that 37% of you have chosen option A as the correct answer, and 34% of you have chosen option B as your answer choice. All right. Now, before I move into this question, um, I want you people to answer in the short answer poll. Did you people observe this point that I have to find out integer x? Because everyone who marked option A as the right answer made a mistake in that. So let's discuss the solution for this question. All right, let's move into the solution. So in this question, it has been asked, what is the minimum value of integer x? And we have been given two inequalities, right? And we already know the first inequality. Let me clear all the answers. All right. Okay, we already know the first inequality. We solved it in the last question. So from the first inequality, we know that x is less than minus 2. And I need to find out the minimum value of integer x. So this is a constraint given in the question that x is an integer. And then I have another inequality to solve. Now, if I solve the second inequality, I bring x to the left hand side, take 17 to the right hand side. I get that the value of x is greater than equal to minus 5.5. So now I have two values of x, right? X is less than minus 2 and greater than minus 5.5. So if I draw them on the number line, this is what I would get for the possible values of x. It lies from minus 5.5 to minus 2. So there are three possible values of x since x is an integer: minus 5, minus 4, and minus 3. And hence, since I need to find the minimum value, the answer becomes choice B. So every one of you who chose option A as the correct answer missed out on this very simple thing, that x is an integer. So even after doing the entire question with the same process, just with missing out on a constant costed you the entire question. Right, so I would again request all of you to read the question statement properly and pay some special attention to the constraints given in the question. Constraints are something that we should always note down in our paper where we are solving the question. So please make this a habit. Before you mark the answer, check with the constraints whether you are going right or wrong. Right, and ensure that at every step you keep the intermediate values within the given constraint. In that fashion, you reach to the final answer without ensuring that you did not have created a mistake in the solution part. Right, with that, let's move on to the third question. So I'm going to clear all the answers. I'm going to open the poll. Why don't you select still solving? Okay, so 40 people. Let's get some more people. 52. Let's get 6 more people. 55, 58. 2 more, 59. 1 more, 60. Thanks a lot. All right, let's move on to question number 3. All right, another 5 seconds. 4, 3, 2, and 1. All right, let me end the poll here and broadcast the results. So let's see how you did in this question. So 44% of you tell me that the answer for this question is option A, and almost a fair share between options C and D, with 20% each. All right, now let's move on to solving this question. Okay, so let's discuss the answer for this question. Now, I need to find out the range of values of z square, given that z square plus 4 times z square minus 2 is less than 0. So when we are being given this inequality, we need to find out the range for z square. Keep that in mind, not z, but z square. Now, z square, since that is a perfect square, is always non-negative. So this is a constraint in the question, which the question doesn't explicitly mention, but that's something that we always need to keep in our head, right? Z square, since it's a perfect square, is always non-negative. So I cannot have any option, I cannot mark any option in which the value of z square goes to negative. There's another thing we need to check to solve this question, and it's essentially, I would rather say a tip for all of you in solving the next questions of these type. Now, z square plus 4 is again a perfect square, or essentially not a perfect square. I'm sorry, it's a positive number, because z square is a perfect square and is non-negative. Plus 4 to that would make z square plus 4 a positive number. And when I multiply any positive number in any inequality, the sign does not change. So if I take out that part from the inequality, the sign of the inequality is not hampered at all. So in this question, what we are going to do is simply eliminate z square plus 4 from this inequality, because that doesn't add any value to this inequality, right? The only reason for which this entire inequality is a negative number is because that z square minus 2 is a negative number, right? So z square minus 2 is a negative number or less than 0, and we add 2 to both the sides of this inequality to get that the value of z square is less than 2. Now, since z square is less than 2, and we also know that z square is greater than equal to 0, then the final range for z square becomes from 0 included to 2 not included, which is option D. So 20% of you got this question correct. Now, people who marked option A and option C as the answer, I want you to tell me, where did you falter? Please put that answer in the short answer part. Where did you guys falter, and why did you mark options A and C? Okay, so almost everyone tells me that they forgot to consider that z square is a non-negative number. Again, so my request to all of you, as far as these questions are considered, is to look at the constraints. Now, this is a feedback that we are continuously getting from all of you, right? So look at the constraints, and that would solve, that would help you in solving the questions with much more accuracy. So Sadia has a question for me. Why can't z square plus 4 be a negative value? Now, z square, as we know, is a perfect square, right? So it's a non-negative value. Z square is a non-negative number. With a non-negative number, I also add a 4, which is a positive number. So the entire value now becomes positive, right? So that is the reason we eliminated that from our question. All right, so what I'm going to do is stop broadcasting, reopen the poll, and you people need to select still solving. Let's get 60 people select still solving, and then let's get to solving the fourth question. 56, let's get 4 more people, please. Four more people. Okay, I have a 58, I have 59, just one more. Let's get to that 60 mark. 60 it is, all right. Thanks a lot, guys. Let's move into the fourth question. All right, last 5 seconds for this question. Four, three, two, one, and zero. So I'm gonna end the poll. All right, let's talk about this question. But before that, this is a very synonymous question to the last question itself, right? And we'd use the same information that we, got in the last question to solve this one. So let me broadcast the results and see how you people fared. So 43% of you tell me that the answer for this question is choice C, and a fair share between choices A, B, and D. All right, let's move into solving this question. Now, solving this question becomes really easy because we solved the last question in which we had that the values of z square can only be from 0 to 2. 0 was included because z square is a non-negative number, so it can be 0 because 0 is a non-negative number, right? Now, here there's one extra constraint, additional constraint that's given in the question, that is z is an integer. Now, if z is an integer and z square lies between 0 and 2, what are the different integral values of z square? It's either 1, it's either 0, or equal to 1, right? So when z is equal to 0, z square is equal to 1. Where z is equal to 1, z square is also equal to 1. So these are the two possible values of z square, and hence we mark options C as the correct answer choice. Now, people who marked options A and B and D, let me ask you this question. Where did you guys falter? Please mark your answers in the short answer poll. People who chose options A, B, and D, where did you falter? Did not include 0. Two values of 0, right? It's either 0 or 1. Incorrect take. Oh, that would hurt, but it's still all right. You can always change your answers in the polls if you feel that you have marked incorrectly. It's completely okay. Okay, so I see some people again missing the constraint that they missed the part 0, they missed the part that z square z has to be an integer again. So this is where I would say that reading the question statements properly is really very, very important if you want to get to a good score in quant. So please ensure that you are on the same page, right? Okay, and another important key takeaway is that a perfect square is always non-negative, right? It can be equal to 0, or it's other than 0, it can also be a positive number. So with that, let me end the poll here, clear all the answers, and I'll also reopen the poll. Why don't you people select still solving? and let's get to the next question. The next question is my personal favorite, and I am really hoping you people, I am really hoping that you people will enjoy solving that question too. All right, so I have 35 people. Let's get another 20 people. Mark still solving. So this essentially helps me pace the session. When I see that 80% of you have marked an answer choice, I'll call it time and then we discuss. So that's the reason we ask you people to select still solving. All right, let me end broadcast and let's go to the next question. Question number 5. All right, another 10 seconds for this question. So if you have not marked your answers, please mark so. 5, 4, 3, 2, and 1. All right, let me end the poll here and broadcast the results. So I see that 26% of you tell me that the answer for this question is choice E, and almost a fair share between B, C, and D. Also, 6% of you tell me it's choice A. Now, before I go to the solution for this question, I want you people to tell me how was this question. So I'm going to open the short answer pod and you can type in your answers. How was this question, guys? Was it difficult, easy, time taking? All right, so we are going to check this question. We're going to discuss this question, and then yes, this is a 700 level question, and let's see how to solve this question, right? So what I would do is I'm gonna end the poll here, and let's keep all the answers as they are right now, and then solve the question. I'm gonna ask you the same question once more after we solve the question, whether you people have some change in your answers or not. We'll see that. Right, so for this question, let's see how do we do it. So we are given that x and y are positive integers, so is that x plus 2y is greater than 20 and 3x minus 30 is less than minus y. I need to find out the positive difference between the minimum possible value of x and the minimum value of y. Okay, so difference between the minimum value of x and the minimum value of y. So it's given to me that x plus 2y is greater than 20 and 3x minus 30 is less than minus y. It's also given that x and y are positive integers. So this is something that we have to keep in our head. All right. So the first thing to solve this question, we need to change both the inequalities into their standard form. So let's keep everything at one side of the inequality so that adding the inequality really becomes easy when we find that the sign of the inequalities are same. So we see that when I change it to standard form, the first inequality becomes x plus 2y minus 20 is greater than 0. And the second inequality becomes minus 3x minus y plus 30 is greater than 0. Now, why did the sign of the inequality change? Because we multiplied this entire inequality with minus 1. The only reason for which we change the sign of the inequality is now that we have both the inequalities with the same sign, we can essentially add the inequalities together. But before that, there's one small step. Now I have a plus x here, I have a minus 3x here. So what I'm going to do is I'm going to multiply the first inequality with 3. And what do I get? I get 3x plus 6y minus 60 is greater than 0. Then I'll add this inequality with the inequality that I previously had. So with this, what do I get? I get y minus 6 is greater than 0 or y is greater than 6. So this is the first thing that we would end up with, that y is greater than 6. Now if y is greater than 6, what is the minimum value of y considering y to be an integer? It's equal to 7. So I have the value of y. Now I need to calculate the value of x. Right. So with this, what do I have? I have y minus 6 greater than 0, right? With this, what I would do is I'll add this inequality, my second inequality. I can cancel out y, and then I see that the value of minus 3x plus 24 is greater than 0, or minus x is greater than minus 8. When I multiply both the sides of this inequality with minus 1, the sign of the inequality would change, and I see that x is less than 8. Now x is less than 8 and x is also a positive integer. So what is the minimum value that x can take? The minimum value of x would be equal to 1. Now that we have the minimum values of both x and y, the most simple part now comes. So we just need to find the difference. The difference between 7 and 1 is equal to 6, which makes option E the correct answer choice for this question. So now tell me, is this question clear to all of you? Mark a yes if it is. Is the question clear to all of you? The solution clear to all of you? That's really great. Okay, I'm gonna open the poll here. But I'm also seeing some people confused with the solution. So people who are confused with the solution, why don't you tell me which is the area where you are confused with? Please mark your answers in the short answer poll. What is the area that you are confused with? Okay, so what did we need to calculate? We have the minimum values, right? We have the minimum values. So in the question was asking me what is the positive difference. If you see here, it's given what is the positive difference between x and y. So if x is equal to 1 and y is equal to 7, the positive difference is equal to 6, right? And that is the reason why we marked option E as the right answer. Okay, y is equal to y greater than 6 is also a confusion. So let's get back to the question and see how do we do it. Now, when I add this one, that is 3x plus 6y minus 60 is greater than 0, with 3x minus y plus 30 greater than 0, what I get is the plus 3x and the minus 3x cancel off each other. I have a plus 6y and I have a minus y, so I have a 5 I have 5y in the left hand side, a minus 60 and a plus 30, which means I have a minus 30 in the left hand side. So 5y minus 30 is greater than 0. If you divide that with 5, I have y minus 6 to be greater than 0, or essentially y to be greater than 6. I hope that is clear to all of you. Another question is, how is the minimum value of x equal to 1? Now it's given in the question that they are positive integers, right? And what is the smallest positive integer? It's equal to 1. So when I subtract, so that is the value of x, the minimum possible value of x. And when I subtract that from 7, I can get to the answer. With that, I hope the solution for you is clear to all. The solution is clear. Yes, there has been a small mistake. This would be y is greater than 6 and not 8. Sorry for this, guys. This would be y is greater than 6. All right, so let me end the poll here, clear all the answers, and now I'll open the poll. Tell me, is the solution now clear to all of you? Is the solution now clear? All right. Did you enjoy this question? And this was a very good question. It was one of the best questions of tonight. So, and this is my personal favorite. Right. All right. So what I'll do is I'll clear all the answers, and I'll also end the poll, clear all the answers. From here, we'll move into the next question. And now we are moving to solving DS questions. So why don't you mark a still solving? And let me reopen the poll, clear all the answers. Yes, please mark a still solving, and let's go to question number 6. Okay, I have 44 people. Let's get some more. Let's get to 50. We need another 2 people. 49. One more person. That's good. All right, we're now moving into the GMAT level questions. This is the first question. All right, 10 more seconds for this question, guys. 10 more seconds. If you've not marked an answer, please do so. 5, 4, 3, 2, and 1. So what I'm going to do is I'll end the poll here and broadcast the results. So let's see how you people answered. So I have 15% of you telling me that the answer for this question is choice A, around a fair share of people telling me it's C, T, and E with 25, 17, and 22% respectively. All right, let's go and solve this question. Now, this is again a very nice question, and it's given that z is an integer. Again, so one very important constraint that we have to keep in mind that z is an integer. Then it's also given that mod of z is less than 6. We need to answer whether z is positive or not, and then we are being given two statements. All right, now the question has a lot of information. So first, let's decipher all that information that the question presents us. It's given in the question that z is an integer, and it's also given that mod of z is less than 6. Now, if mod of z is less than 6, it essentially means that the value of z would lie between -6 and +6, right? So what are the possible values of z? It can be -5, -4, and that will go on to +5. So there are 11 possible values of z. Now, before I move on to the next part, let me bring you the yes no poll. Open the poll. I want you to tell me how many of you did this process. How many of you did this step before going into the statements? How many of you did it? So I see almost, 1/3 of the class telling me that they did not do it before going to solving the statements. So another feedback from this question is before we move into solving the question statements, essentially the statements, statement 1 and 2, we would, it would be really nice if you interpret the question and we write everything the question presents us. So before going into the analysis of statement 1 and 2, we also need to do a question statement analysis. It really helps you a lot to solve difficult GMAT questions very easily, right? And now that we have this information, even you people would see how does that help you going to the answer. So what I'll go do is I'll hide the poll. I'll end the poll here. Let me clear all the answers. All right, so now this is the information that I'm moving forward with. Let's go to the first statement. The first statement tells me that mod of z minus 2 is greater than 3. Now, the first thing here is, remember the sixth question that we did. We discussed that we can write the distances only in that fashion when the value is less than some value, right? When I have a less than sign in my inequality. But in this question, in this statement, we had a greater than sign. So anyone who did -3 to be less than z minus 2 to be less than 3 made an error here. Right, so what we need to do for this question is substitute z minus 2 to be equal to t. And according to the statement, we are given that t is greater than 3. If t is greater than 3, then there are two possibilities. T is less than -3 and t is greater than 3. So that means uh, t, that is z minus 2, is less than -3, and t, that is z minus 2, is greater than 3. When you simplify this, you get two possible values or two possible ranges of z. The first is z is greater than 5 when you take -2 to the right hand side. And then when you take -2 to the right hand side here, you get the value of z to be less than -1. Now, if I combine both these ranges together, that z is less than -1 as well as greater than 5, and also keep in mind that z could take 11 values from -5 to +5, because that's a very important point here. So since z can take these values, z cannot be greater than 5, right? So this is not a possible scenario. Yes, z can be less than -1. It's a possible scenario, and we see that all the values are negative. That is from -5 to -1, all the values would be negative. So z is a negative number, and that's what we can do from the first statement's analysis. Right? Since we can answer the question that whether z is a positive number or not, we can say that the first statement is sufficient to answer this question. With that, let's move into the second statement's analysis. Now, the second statement tells me that the value of z mod z is equal to 2. Now, if mod z is equal to 2, there are two possible values. It can either be plus 2 or it can be minus 2. Now, for this, z can either be positive because we have a positive value here. Z can also be negative because we have a negative value here. Now, since we have two different answers, answering this question with this statement is not possible, right? So the second statement is not sufficient. Since the first statement is sufficient and the second statement is not, the correct answer for this question is choice A, which 16% of you got correct. Now, people who did not get this question correct, I'm going to reopen the poll here. I want you people to tell me, where did you people falter? Where did you falter? Okay, so I see a lot of you telling me that you faltered in the first statement majorly, right? Yes, -2 and +2 are both less than 6, but again, one is negative, one is positive. I cannot say for sure that z is positive, right? And there is the point where I made a mistake, right? So that is the reason I cannot take the second statement for this answer. Okay, I have a few queries for the first statement, so let's go to the first statement. Now, in the first statement's analysis, it was given to us, it was given to us that z minus 2, mod of z minus 2 is greater than 3, right? So we just substituted z minus 2 to be equal to t. So now we can write that mod of t to be is greater than 3. It means what? That t is either greater than 3 or is less than minus 3. Then we simply substituted the value of t, that is z plus 2, z minus 2. So z minus 2 is greater than 3 or is less than minus 3, then went on to the values of z to find out the final values. Sadia, I hope that clears all your doubts. Okay, that would be all, I presume, and then let's move on to the next question. So before I move on to the next question, what I would want is you select still solving. So why don't I see 50 still solvings, and then let's move on to the next question. And also in the meantime, I'm seeing a lot of people who are missing constraints. So guys, please understand that you cannot miss constraints because these are difficult GMAT level questions. Even after solving the entire question, spending 2 minutes, if just for a single constraint the entire question goes wrong, then it's upsetting at your end, right? So I don't want you to do that. So please ensure that that you are well aware of the constraints that's given in the question. All right, so what I'm gonna do is I'll end the poll. I'll clear all the answers. We have 39 people. Okay, let's go with 39. Let's go to the seventh question. All right, 10 more seconds for this question. If you have not put down your answers, please do so. 5, 4, 3, 2, and 1. So what I'm going to do is I'll end the poll here and let's broadcast the results to see how you people did. All right, so I see 28% and almost a fair share again between options B and D. So 28% of you tell me that it's option D, and 27% of you tell me it's option B. And I also see some people with going for options A and C. All right, let's look at this question. Now, this is a very fairly easy question, but deciphering that requires a lot of observation skills. So we'll talk about that in this question. The question statement doesn't give us much information. It just tells me to tell me whether A is less than B or not. Okay, I can see a few people with voice issues. So what I'll do is just give me one moment, please. All right, let me get the audio poll here once more and see if the audio is now clear to all of you. Just give me one moment. Okay, can you please mark a yes or a no if the audio is clear to all of you? Now sounds good? That's great. Okay. All right, so what we would do, I'll end the poll here, right? Okay, let's move on to the next part. Let me hide it out. All right, let's move on to the next part. So the question, as I was talking, is a fairly easy question, but we have to, you know, this is something where this is a question where we have to use our observation skills. Then the question really becomes very easy for us. The question statement doesn't give us much of an information, right? It only tells us that it only tells us that it asks us, doesn't even tell us. It asks us whether A is less than B or not, and then we have two statements. So we cannot go to solving the question stem because there's no information. So we'll directly go into solving the statements. So let's go into solving the first statement. The first statement is that a minus b is equal to mod of a minus b is equal to b minus a. Now, let's consider a case of mod x. Now, mod x, if that is equal to y, we can always say since y is equal to a modulus number, then y is a non-negative number, right? So whenever I have this kind of a scenario in any questions, we can say that the right hand side is a non-negative number. It's either 0 or a positive number. So here as well, we can say that b minus a is a non-negative number which is greater than equal to 0, or essentially b is greater than equal to a. This leads us to two cases. First is a can be equal to b as well, and second, a can be less than b, right? So two possible cases from the first statement's analysis. Now, can I answer whether A is less than B? For one, I cannot. For one, I can say that yes, it's not. For the other, I can say no, it is, right? So basically, I'm getting two different answers from the same question statement. So hence, I can say that the first statement is not sufficient to answer this question, right? Let's now move on to the second statement. But before moving on, let me reiterate the fact again. Whenever I see modulus of some number is equal to some other number, then I can say that the right hand side is always a non-negative number because I have a modulus expression in the left hand side of the equation, right? So this is a very important key takeaway from this question. Let's now move on to the second statement's analysis. The second statement tells me that a by b is less than 1. So this leads us to two possibilities. If b is a positive number, then if I cross multiply, then I get the value of a to be less than b. However, if b is a negative number and I cross multiply, and I also need to multiply that with a minus 1, then I would see that a is greater than b. So again, for the same question, two possibilities. A can be less than b, a can be greater than b. Can I answer my primary question, which is a less than b? No, I cannot. Since I cannot answer this question, even statement 2 is not sufficient to answer this question. So after this, what I do? I essentially combine both the statements together and see if there's a possibility of an answer that I can get. So from the first statement, I had two possible cases. Either A is equal to B or A is less than B. From the second statement, I have two possible cases. A is less than B or A is greater than B. When I combine, these two are the same cases, right? So I find a zone which is common to both the statements. Now, since I find this zone, I can say that yes, A is less than B. So after combining both the statements together, I can answer the question that tells me that the correct answer for this question is option C. Okay, so I have a question from Shobit. Can we write mod of a minus b to be b minus a? Why would I do that again? So I essentially don't want to go into that part. Whenever I see that I have a modulus sign, Shobit, I'll just take the right hand side to be a non-negative number. That would do what? That would help me in negating, the cases that's not required, right? I'll save time. That's the only reason why we would do that. Cool. Okay, now let's move. This question is clear to all of you, I presume, right? I have another question from RC. What if in the second statement, what if B in the second statement is negative? Yeah, if B is negative, RC, we already discussed, right? So when we cross multiply, we get what? A is less than B, but B is a negative number. So we have to convert that into a positive number. So it would be the sign of the inequality would change, right? It would be a greater than sign. Okay, so let me explain this question once more. I see a few people having an issue with this question. Let's go to the first statement. The first statement tells me that mod of some number is equal to b minus a. Now, so b minus a is equal to mod of some number, and we know that modulus is always a non-negative number. So b minus a is always non-negative. So it's greater than equal to 0. And if I take a to the right-hand side of this inequality, I get b to be greater than equal to a, which leads us to two possible cases. Either a is equal to b or a is less than b. So can I answer this question of whether a is less than b or not? I cannot, because from one I can say, from the other it's giving me another answer, right? So that is the reason the first statement gets insufficient. The second statement also on the same lines. I have a by b to be less than 1. So when I multiply b with in both the sides of this inequality, I end up with b to be on the right hand side, and I can write a is less than b. Now this I can do when b is a positive number, right? So when b is positive, I can write a is less than b. But when b is a negative number, I need to change the sign of the inequality as well. So then I write that a is greater than b. I hope this is clear to all of you. For people saying that I can take the first statement to be plus b minus and minus b minus, you can do that. You would get to the same answer, but it would essentially take up a lot of time, right? So that is the reason I don't want you to go towards that part. Okay, Chin tells me that for statement 1, I took positive and negative scenarios. Positive led me to A equal to B. Negative led me to tautology. Hence, I assumed a statement 1 sufficient. No, again, will not do that. Will not take it to be positive and negative. We'll just consider that to be a non-negative value and then go on solving. So the left-hand side is not required from me. I'll only consider the right hand side and solve the question. I hope Chin, it's now clear to you. This question is now clear to you. So with that, now, a very, very important question to answer is: do you people think that mastering GMAT quant is difficult? Now, if you people think that mastering GMAT quant is difficult, then no, it's not correct. You can improve from a low quant score to a very high quant score the moment you start focusing on learning and not going to that areas of learning shortcuts or learning short tips and tricks for questions. Now GMAT is a very structured exam, and that is the reason they also want the test takers to be very structured at their own end. So plugging in values, taking random examples, solving question via options would only do good if the question is easy. But I hope all of you want to go to that Q50, Q51 level, which is the difficult level. And in that, I would say that those shortcuts, short tricks won't apply. The only things that would apply is a proper formal process. Now, for attaining that proper formal process, I want you people to leave shortcuts and everything behind and just solve questions with proper statements, with the proper methodology, with the proper approaches, the straightforward approaches. So yes, it's not at all that you need to be a math wizard to master GMAT quant or an engineer to master GMAT quant. You just need to have 100% conceptual understanding, and you need to apply those process skills. You need to, apply those concepts that you have learned to solve questions. And as far as process skills is concerned, the different skills that we discussed, looking for the constraints, translating difficult questions into easy questions by reducing the information, by reducing the complexity of information presented in the question. So it's a structured approach, which I want all of you to embrace. It might be difficult for the first 1-2 weeks, but once you embrace the structured approach and not shortcuts, it would really help you a lot to solve those difficult GMAT questions in which anyway the shortcuts don't apply. Now, in the following slides, going to showcase examples of students who have different starting points and who have excelled in GMAT quant. And I really hope that you find some of the other story aligned to your story as well. You would notice that while each of them started at a slightly different point, all of them had these commonalities in their journeys that helped them succeed. So the first success story that I'm going to share with you is of Krish. Now you can read the full story on GMAT Club. He has a verified review there. Now Krish had always excelled in math, right? But despite being a topper in math, he was unable to solve, he was unable to excel on GMAT quant. Why? Because, like many of you, he would just jump to solving questions, ignoring the implicit and the explicit constraints mentioned in the question, which in our session we saw that you people were missing constraints. And many a times not considering all cases. So he failed to consider all cases and he failed to draw inferences from the question stem. But once he understood the e-GMAT way of doing things, he understood that he needs to take a step back. Math and GMAT quant are two completely different zones. So he started applying those process skills and then started solving questions. And once he did that, he improved from a Q48 to a perfect Q51, scoring a 740 in the exam. Now let's look at another story. The second story that we are going to discuss is of another student, Leonardo. Now Leonardo is a South American. Now he's a student who was again good in quant, but despite being good, he was not being able to cross the Q45 mark. There were two things that were stopping him. First, he did not follow a methodical approach, and then there were some topics such as inequalities where he did not know the fundamentals. The key success for Leo was to first identify the weaknesses, which he did using the Scholaranium tool. And I really want you people to take a look at the Scholaranium tool and the data that the Scholaranium tool gives you. Now, with that, he improved to a Q49. Now, Leo was able to get into Stern, Tepper, and Wharton, and ultimately went into Wharton. And a starting score of Q45 was really really a distant dream, right? Wharton was distant dream with a Q45. So again, so he developed that methodical approach, and he used a lot of scholaranium, and the data that the scholaranium tool gave him really helped him to understand his key areas where he lacked, to improve them. So the scholaranium is where I want you people to focus next. This would give you the idea of your overall ability. Now, not only ability in a subsection, but also would tell you what is the ability in all the sub concepts. So whether you are good at quadratic, average in inequalities, good in exponents, and not that good in functions. So with this data, what you can do is you can precisely target your weak areas. To improve algebra, you don't have to focus on quadratic and exponents because you are already doing good. You need to focus on functions first and then go to inequalities to raise the 64 percentage into maybe a 90 or a 95 percentage. So the data that the Scholaranium gives you is really great, and you can access Scholaranium for free if you go to the e-GMAT free trial. You just need to log in into your account, and then you can access Scholaranium. The next success story that I want to discuss, and this is my personal favorite, is a student whose quant score is really less, and it's almost synonymous to a lot of people in this session, right? So if you have a low quant score, it's not a worry. So let's understand what Mazibar did. So he was stuck at a Q30, which is around the 20 percentile in GMAT quant. He spent a lot of time reading quant books, but even with that, he could not increase his score. He used our course and used the learning methodology that we essentially have, and cemented on that learning process. This is exactly what we did in the webinar as well. So we started off with concepts and easy questions, and then slowly increased the level of difficulty of each question, right? So the first question, if you remember, you only took what? You only took 30 seconds to solve. The last question almost took you 3 to 4 minutes to solve, and it was also a difficult question, right? So this is a progressive learning methodology that even we have in our courses, right? So now, because his basics were not that strong enough, the system, the Scholaranium tool, and our own e-GMAT system kept on telling him, kept on giving him a constant feedback, and then he used that feedback to understand the gaps in his preparation and worked on them. So from a score of 20 percentile, he went on to score a Q45, which is almost a 60 percentile, right? The next story that I want to discuss is someone who did not know the basics to someone who excelled on GMAT Quant. From a Q38, he went on to improve to a Q50. Now, Guillermo was got into Wharton, and he used our learning technique. He built an approach. He started off with basics, built an approach around the basics, then used the Scholaranium tool to understand where he lacked, focused on those places, and then went on to scoring a Q50. The reason I especially like this example is because it demonstrates that you don't need to be disheartened by a low starting quant score, right? Because as you can see, he had a quant score of 38, which is quite low. And in the first poll answer that you people answered, a lot of you were below the 38 level, and it's completely fine. What you need to do is simply understand, take up the challenge. You need to believe in yourself. Start from learning the basics and work your way up step by step, and I'm pretty sure you would do just great. So essentially, to ace GMAT Quant, you need to do is focus on learning and adopt some good habits. Do not go into that shortcut methodology. It won't help you much. I want you people to go towards learning solid concepts, to learning apply to know applying those concepts and following a proper approach to solve questions rather than shortcuts or using options to solve questions. So get started right away. You have the access to the e-GMAT free trial. You just need to log into your account, and you can access the videos and practice quizzes and mock exams as well at your end. As next steps, what I would say is have a 200% clarity in your concepts. Ensure that you solve questions in the proper approach, in a step-by-step fashion. Become an active reader of question statement, because I do not want you to miss constraints as we did in today's session. Also, trust the test maker. He would not throw difficult things at you which you cannot solve. Like he won't ask you to solve what's the value of 17 to the power, let's say 20. He won't do that because that's out of scope for GMAT, right? And lastly, believe in your skills. I would be I would be telling this to you. This is the most important thing that you need to do even before learning the concepts. You need to have a proper belief in yourself. If you believe in yourself, you can do everything, right? You have everything in your arsenal to solve any question. All you need to do is keep faith, right? With that, go to the free trial, do all these topics, practice the questions, the session PDF. I'll be sharing the session PDF in another minute. And I'll also ask you people to use the quant scholaranium, the algebra scholaranium, where you have around 35 questions, and also understand the data that the scholaranium gives you. It's really helpful. It would be a lot of help to you. With that, let's go to the next page, where I would want all of you to answer me two very important questions. First is, what were your key takeaways from this session? And second is, now what do you think is your comfort level in algebra? So please give me the answers to these questions. And also, if you could please rate the session out of 10. Rating the session really helps us be motivated, and it also gives us a feedback on the session so that we can improve the next time we go around this. And I would also want you